Can you see it okay? So it says, use the formulas below to convert between Cartesian, which is rectangular, and polar equations. So this is 413, the last bit of new knowledge before you spend a few days reviewing and practicing. So it says sometimes the converted equation comes out simpler or more complicated than the original. The benefit of being able to write an equation in two different systems, polar and rectangular, allows you to choose the simpler version of the equation to graph. So some of the equations look horrible in polar. There's a reason we learn them in our rectangular classes or rectangular studies, and vice versa. So here are kind of, I'm rewriting some conversion factors from over there. We know that r squared is equal to x squared plus y squared, right? Because that's the Pythagorean theorem from the triangles. Isn't it interesting that in our study of conics, x squared plus y squared equals r squared is the formula for a circle, right? So it directly links writing something in polar with writing something in rectangular. We just studied the equation of a circle. When we did a circle, we just wrote it in the reverse order. X squared plus y squared equals r squared. The tangent of theta is equal to y divided by x, right? That's the ratio from the right triangle. And we know that x is r times the cosine of the angle, and y is r times the sine of the angle. So we're going to use these to go between the two systems, polar and rectangular. So if I just had r equals 3, which is how I write a circle in polar, how would I rewrite that using rectangular or Cartesian coordinates? So I see up here an r squared, so I could easily square both sides of this equation. And if I have r squared in the formula, can't I replace that with x squared plus y squared? So sometimes you'll have to do a little bit of algebra. So in this case, I'm just going to go ahead and square both sides of the equation. So I would have r squared equals 9. Can I substitute in for r squared, x squared plus y squared? So isn't this the rectangular form for a circle with radius of 3? So this says circle with radius of 3 in polar. This says circle with radius of 3 in rectangular. Do you think one is easier than the other? I think they're both okay. They're pretty much, I think, the same in difficulty level. R in polar, it stands from the distance from the origin. In our rectangular world, we were talking about it being the radius of the circle. So r is the distance from the origin, r comma theta. All right, so this looks really ugly right now. How would I convert this whole thing into polar coordinates? You could maybe simplify it by dividing both sides by x. So let's do that as our first step, I guess. So if I divide everything by x, I would have 2 minus 5x squared equals y. So I'm getting somewhere. So do you know what equation this is of in rectangular? What type of shape is that? It's a parabola in rectangular worlds, right? So I need to change this into polar coordinates. Guess what? It's not really pretty as polar coordinates. Do I have anything up here that says x squared that I could substitute out? No, I have this one. Do I have a y squared in the problem currently? I just have a y. So I could change this conversion factor to an x squared, couldn't I? R cosine theta times r cosine theta. I have a y substitution factor, so this is going to look a little bit ugly. So don't let the ugliness deter you. This would be 2 minus 5. And if you want to substitute it in, it's r cosine theta squared equals r sine of theta. So I'm substituting this in for x, squaring it, and I'm substituting this in for y. And when I skim through this second row, do I see any x's and y's left in the problem? So I just converted it into polar form. Does it look any better in polar form? I would have kept it like a quadratic at this step, I think. So sometimes things look better in rectangular than in polar. I really, really want you to know a circle in both rectangular and polar, because that's kind of the link between these two kind of mini topics. All right, what about this one? Convert r equals -8 cosine of theta into Cartesian coordinates, and then use completing the square technique to transform the Cartesian equation into something more recognizable. I see a cosine of theta. What is cosine of theta linked with up here, though? X. But do you see r times cosine theta in your problem? So what you would have to do as your first step, I'm just rewriting the problem. How could I make this side say r cosine theta? I would have to multiply through both sides of the equation by r, actually. So I'm not expecting you would know how to do that without me telling you. But now that you know you're shooting for r cosine theta, the only way to get r cosine theta is to multiply by r on both sides. So you'd get r squared equals -8 r cosine theta. Now you should see up top two things that you could directly substitute in. One thing for r squared and another thing for r cosine theta. What can I put in for r squared? So this side of the equation is x squared plus y squared. And this side of the equation, someone said I could just write that as x. So I have -8x. I did, you're not going to divide by x because you have a y squared term. I'm going to use the completing the square technique. So I need to get that 8x on the other side with the x squared. So x squared plus 8x, leave a little bit of room to complete the square. I just added 8x to this side, but I squeezed it in between so that it'd be next to the x squared term. I left y squared still on the left-hand side of the equation, and now it's equal to 0. I'm trying to complete the square. So I went from polar to rectangular. I'd like my rectangular equation to tell me, is this an ellipse? Is it a circle? What's the radius? Yes. Let's finish it. So what do I do to complete the square? So I add half of the b value, 4, and square it. So add 16 to both sides of the equation. So this is x plus 4 squared. X plus 4 squared plus y squared equals 16. So how did Parker know that this was a circle? How did he know just by looking at this equation over here that it was a circle? What did he notice about the coefficients of x squared and y squared? They were both 1 or they're both the same. So even if you had divided through the equation by 16 to get a 1 over here, the denominators would have both been 16. So your major and minor axis of the ellipse would have been the same length. So it's a circle, right? So this is really a circle with a center at -4, 0, with a radius of 4. And if you graphed it in polar form on your calculator, that's exactly what it would look like. So you go to mode, polar, and it was just, what was it? R equals -8 cosine of theta. Well, if I do zoom, square up the axis. So there's my circle, right? I couldn't really graph x squared plus y squared on my calculator in rectangular form, but I could graph it in polar form and prove it to you. So it does link, it's a loose link, but it is linking our study of conics and writing a circle to our study of polar and writing a circle. You kind of see the connection there a little bit. All right. That is beta. So when you're talking about angles, you can use some different Greek letters like theta, alpha, beta. So this first one, these are just common polar graphs that you might see. So for example, if you see theta equals some angle, so for example, theta equals pi over 6, or theta equals pi over 2, all those are lines, right? They're lines. So theta equals pi over 6 is just a line that goes through the origin at 30 degrees, but it extends forever. So theta equals pi over 6 is another way of writing this line. I don't know the slope of this line without finding the, what would it be, the tangent of y over x, or tangent of 30, root 3 over 3. It has a slope of root 3 over 3. What about pi over theta equals pi over 2? That's just a vertical line, right, at pi over 2. What about theta equals pi over 4? You should know the slope of that line. What is the rectangular equation for that line? What is it? Y equals x, right? Because the slope is up 1 over 1 if it's a 45-degree angle. So just recognizing if it's angle equal to, and they give you a measurement, it's just a straight line. What kind of a line is it if it says r cosine theta equals some number? So for example, r cosine theta equals 5. What does that look like? Yeah, that's x equals 5, so it's a vertical line at 5. So to me, x equals 5 is the simpler, more recognizable way to write a rectangular vertical line. But r cosine theta equals 5 just means the same thing. And what does r sine theta mean? Y equals, right? So it's a horizontal line. So if it was like r sine of theta equals -3, that would just be a horizontal line at -3. So just recognizing, I'm not going to have you graph really challenging, intense polar graphs. Just kind of recognizing, hey, there's those conversion factors over on the left-hand side. And maybe if you see something like r sine of theta, you'll realize that's just like y equals. So then this one was number 7, just graphing a few different lines on the same axis system. So maybe you could try graphing this line or this equation, and this equation all on the same axis just to get practice. This is a rectangular axis, not a polar axis, so just do your best. And then I will show you number 8, because number 8 is a little bit of a challenge. So just kind of recognize what kind of lines are these. Yeah, you're drawing lines in the correct angle or position. And let's see, this is y equals -3, so just a horizontal line at -3. So just drawing lines, right? To me, they're easier in rectangular form, but you could recognize them in polar. So this last one, this is the same as r equals 2 divided by the cosine of theta. And I told you we weren't really worrying about the reciprocal identities, but cosine and secant go together. I always remember it because they don't start with the same letter. So like sine goes with cosecant, secant goes with cosine, and cotangent goes with tangent. So they don't start with the same letter. That's how I remember that cosine doesn't go with cosecant. There's no pairings with the same number, first letter. So I see an r and I see a cosine theta. And if they were just together, I could substitute in an x. So what could I do to get them together? How can I use some algebra and move them? Multiply on both sides by the cosine of theta. If it's in the denominator, couldn't you multiply on the left and the right by the cosine of theta? Don't you have r cosine theta now equal to 2? Which is x equals 2, right? Vertical line. So it's just being able to take something up here that looks so foreign and just being like, oh, that's just a vertical line at 2, right? So you're simplifying it to rectangular just to recognize it. All right.